There we go. Ian.
Hello, Mike. Good to
So,
see you.
yeah, so what
Yeah.
about you? How have you been?
Oh, I've been pretty good. Gadding around the world too much, but otherwise I'm fine. You've been very busy. I mean, you're always very busy, but the reason we're talking now is because you sent me that remarkable paper, which, with your permission, I put up on my Substack, and which I think is going to be the contribution to that book from the conference about my stuff in California last year. So I'm very grateful for that and for the ideas, and I thought there was just a lot of richness in it, and it would be worth talking about it. So yeah,
Absolutely, absolutely. Thank you so much. I value very, really, really value your opinion and taking the time to read it. So that's great. I hope I hope I'll send you the latest version for your site and everything because I'm not sure.
oh, okay.
I'm not sure if I had the, whatever, what you had at the time you put it up. I'm not sure if it's the latest one. So I'll send you the latest one. But
I think it was version 23, if that's any help.
yeah, that's pretty good. Close enough. Close enough.
Close enough. But no, I'd like to have it, and then I can put that up instead. Yeah. Yes. So, and I saw you did something with my friend Alex Gomez Marin the other day.
I did. Yeah, we had a very good, we had a very good discussion. Yeah, that's great. Yeah,
Yeah.
yeah. I love talking to him. Yeah, he's great.
No, he's a good man. Yeah, there were a whole lot of things that I think it would be interesting to talk about. I mean, mainly on a philosophical level, but then, I mean, I'm glad to say you're not frightened of philosophy, which is completely wonderful, because it's not true of every biologist. And I do think that philosophy and science need to walk hand in hand. Really, I mean, either of them is lacking if it doesn't have the other. So what would you say about the idea that I think you would agree with, you seem to say that intelligence goes all the way down, really. I mean, in everything, not just in life, actually. Is that right? I mean,
Right.
the whole cosmos is imbued with a kind of intelligence.
Yeah. I think that's fair.
And so would you say you're a panpsychist?
I am with a little bit of a twist in that I think the typical panpsychist position, which is one thing that gets critiqued a lot for, is this idea that well the consciousness or the mind of the collective has to be in some way a sum of or
Oh,
it's created.
yeah.
So there's some sort of addition problem, right? So
Totally. Yeah.
right. So I think that's not a thing. I think yes, the parts have it and the whole has it, and it's not
Yeah.
it's not an addition problem.
Oh, thank goodness you said that, because a lot of people have said to me, because I think in a way I'm a panpsychist, but what about the combination problem? And I say, well, it's only a combination problem if you think about it in the wrong way. If you think about it as having to be the sum of a whole lot of different parts, but in fact it's something that, as you say, both in the whole and in the parts, is pregnant with, if you like to put it that way, with some kind of mind, some kind of intelligence, which I think is also characterized by goal directedness, and that by that I certainly don't mean that there is a determinist outcome, there is a deterministic outcome,
Mhm.
but that there is nonetheless direction, and direction doesn't close down possibility at all. But it seems to me that we now have to give up the idea that which was given up by physicists, I guess, some time ago. But the idea that really everything is just random and has no sense of order or direction to it.
Yeah, yeah. I think this combination problem comes from two underlying motivations. One is that I think people really want to, as is, for example, codified in IIT, they want there to be only one mind in anything, right? So if you have a system, the parts, if it's made of parts, well, let's show us the one kind of mind it has, and the part we can forget about what the parts are doing. So I think that's a problem is that you try to right. I mean, I like a continuous hierarchy of overlapping minds, right? And then
Yes.
the other is the even more pervasive thing that we somehow make minds, and so the idea is that from these things we're going to create this thing from sort of from scratch, and then you have this combination problem because you have to say, well, how exactly was
Yeah,
this made?
yeah.
So yeah, I think if we avoid those two things, then I don't think there's a combination problem.
No, no, I completely agree. And it's a relief because I hadn't read you saying that. And as I say, it's a constant uh, gripe I have. This is the thing. In some ways, it's the thing in my terms, very much as the left hemisphere will construe the world, that it's made up of bits, and the bits have, everything that you find in it can be accounted for in the putting together of these parts. We put it together in the way that we put machines together. And I mean, we need to talk about that, but I know you say that effectively there is no difference between the machine and the organism. I mean, I think, I don't know whether you would deny that, but I think that there are profound differences between mechanisms and organisms. But I draw the line, I don't say that there is a sharp line that divides in what we call inanimate matter from animate matter, in other words, life. I think it is a matter of degree. And I think, like you, that there is a, a hierarchy, if you like, in which things are nested. And in that hierarchy, we have the inanimate as well as the as the animate. And the difference is that the animate is just somehow a billionfold more responsive to whatever it is that we find, this intelligence, this directional process, this lure towards things. Another very important idea, that things are not simply pushed blindly from behind, but actually are attracted towards things. I mean, you say somewhere the sort of the important attractor in the morphosphere, I think is the word probably, that draws things towards them. Do you want to say anything about that?
Yeah, a couple things. Well, we can talk about the machine organism thing, and I completely agree with you that on that spectrum there are regions which we have named, which have vastly different properties, and of course it makes sense that to distinguish these things as a kind of a large categories of things. But I think also, but anyway, we can talk about that. I want to talk about the just for a second the attraction bit. Um, th-
Mm.
this is very much in progress, so I don't have anything concrete yet to show you. Although there's other people that have done relevant things, but I've been working on this scenario where we view so let's say you have an agent that's sort of exploring some problem space, so they're trying to find a solution. I've been working on a formalization where the solution is basically reaching out to the agent as much as the agent is reaching out to the right. So a symmetry in this,
That's great.
and the weirdest thing about it. So we can sort of like it almost people. I think people can almost buy that on a kind of human creativity scale. That right that you're that these things are like drawing you. Right?
Calling to you, yes, yes.
Exactly right. So create. I think all creative people have this experience, right? That the thing is sort of like
Sure.
calling you. But the thing that I want to do is, as I like to do, is to show what that looks like all the way down. And when I say all the
Mm.
way down, what I mean is, for example, when you have molecular binding. So you have right in every cell biology textbook, there's a pathway, and they say, well, this thing, this protein that's made over here, and then it goes and finds its binding partner, and then it kind of and there's your pathway. Right? So I remember, and I don't know what the latest. I need to figure this out what the latest quantitative models of this are, but I remember some years back, Roy Frieden did a calculation at a conference in Arizona State of like, how long would it actually take for things in a cell, given realistic, diffusion constants and things like this? How long would it actually take for anything to find its binding partner? Because the problem is that you don't get the reward, so to speak, until you act. So the free energy doesn't drop until you actually get to the thing, and then you bind that. That's great. But along the way, there's no
Yeah.
partial credit, right? There's no partial credit. There's no gradient. You just sort of You just sort of hang around until you find, what you're
Find
right.
it.
And according to that calculation, it would be completely unsupportable, millions of years for anything to find.
Yeah, yeah.
And so, and so we're working on some things to look at what does that actually look, what would, uh, synchronicity, this kind of another way, this library angel phenomenon, right? That you're sort of, you're working on some problem, you're walking through a library, this book falls down, you look, oh look, there's the right. So what does that look like all the way down? What does that look like on the molecular level? What are, could we say that there are ways in which the solution to your problem, or your binding partner in the case of the chemistry, or some other things in AI and so on, are attracting you as much as you're searching for them? So that's, these are very early days, but that's some stuff we're working.
That's fascinating, and for me, it expresses a very important point about existence, full stop, which is that everything is relational. The idea that there are just these things, and then either we find they have relations or we make the relations between them, is again this very reductive view that I associate with. I mean, I'm not just using this metaphorically, this is the way the left hemisphere works. Whereas I think the idea that things are in a kind of partnership, in other words, that there is interdependence, to use this rather wonderful word, which is the title of Kriti Sharma's book on the relationship between an organism and its environment. Not that they just interact serially. The organism affects the environment affects the organism, but they literally co-create one another. So they're coming into being together. Now, you could apply that view to the idea of the solution arriving much faster than you think, reaching out to the problem. That the problem is really a manifestation of a potential solution, and the solution is the manifestation of a potential problem, and they come together. Mm. It is extraordinary how these things do appear to. I mean, I think of a couple of examples. They may well be drawn from your work that I use in The Matter with Things. One well-known one is if you take eyeless, the eyeless gene out of Drosophila, obviously the offspring have no eyes, and if you breed the eyeless flies, their offspring have no eyes. But after 14 generations, without the gene, they have the eyes. So something very powerful is going on very rapidly that says, no, eyes need to be had. And Simon Conway Morris suggests that eyes have been evolved, I think he says 14 different times in the history of evolution. It's an extraordinary thing that they evolved at all, because it's such a complex thing and lots of things have to come together. But the idea that this could have happened separately in different lineages 14 times is extraordinary, and suggests that there is definitely something about having an eye that is quite important. And the other thing that I think is interesting is the idea, and it's closer to what you were saying about it would take far too long, is that when a cell encounters a danger for which it is not in any way prepared, either programmatically or through experience, it can develop an enzyme, or it can develop, at any rate, a change in its chemical milieu that will resolve that problem within as little as 4 days, whereas it would take billions of years if it was just relying on randomness. So this is all absolutely fascinating.
Yeah. Absolutely. Like that last example. Yeah, we have examples of planaria challenged with barium, that basically causes their heads to explode, and then within about a week's time they come up with a new solution that enables them to make barium insensitive heads out of a problem space that's like a 20,000 dimensional problem space, and so we're very interested in figuring out how they do it. And I wonder what your thoughts are about, I've been thinking about this just kind of really broadly, this issue of having this kind of relationship with solutions in that space, right? Let's say I want to talk about the terminology too, so maybe Platonic isn't a good term, as you pointed out, but anyway, there's something, I think there's something interesting going on, and I wonder what you think about this. Like, if you look at the very bottom of the level, you have some kind, let's say photons that, with least action principles, they find their solution. 100% of the time, they don't need complicated internal machinery to calculate which path should I take. They just kind of effortlessly do it, right? They're in that flow state, so to speak, like all the time. Then you have creatures, like when I'm solving some sort of problem, methodically plotting across that space. First I do this, and then what does this mean? And okay, well, maybe, right? So and it's a lot of effort, and you're sort of very carefully crawling along that space. And then you have the people who are the creative geniuses, and they don't need, again, they're back to that initial state. They don't need the step by step thing. They say, oh, it's I can see it. It's obvious. I'm already there. So what do you think about this navigation of that space of ideas? Like, how, why it seems to be like a strange U-shaped kind of thing.
Yeah, that's a very interesting point. And you quote, don't you, Poincaré's thing about, it's not that we have to examine all the possibilities, only a highly selected group of possibilities present themselves for examination. And in a way, in the most exotic examples of insight by geniuses, they go almost immediately to that solution. Not always, but they do. Well, I think, I mean, my view is that, for what it's worth, is that we are equipped with the ability to follow algorithms because they are extraordinarily helpful in everyday living. And, the left hemisphere is very much the utilitarian one that does that kind of thinking. And for a lot of things in life, problem, what do? I do this, I do that, and the other, and it's solved. But I think there is something which allows a gestalt to form and to either slowly or rapidly come into focus rather than to have any step-by-step approach. So instead of thinking of arriving at a solution as the end stage of many steps, if one thinks of arriving at a solution as the the coming into focus of an out-of-focus image, and for some people this image can collapse into I use the word collapse almost advisedly because I think it is something like a waveform making a aha moment there. Now we've got it. That is a process that seems to me, on I think pretty good neurological evidence, to be the way that the right hemisphere prefers to act. And so these two processes need one another. But I think if one's overwedded to the left hemisphere's way of thinking, one actually disattends. So I think we have faculties that by not using them, we are allowing to atrophy, as is inevitably the case, and that other people and people with atypical brains are able to achieve these things by not getting completely locked into the left hemisphere's preferred procedures. And, the archetypal case must be Einstein, who was puzzling about something. He wasn't scribbling. He was playing the piano or playing the violin. And then he'd get up and go, I've got it. So I think, and Poincaré himself has this story about the Fuchsian functions and how he went into town, and the very moment he put his foot on the bus to go home, he realized what the answer was, having sweated over it in the logical kind of way for 2 weeks, staying up at night with lots of coffee.
Mm. Yeah. Yeah. So this is, I think this is a very important area for investigation, where and so I hypothesize in that paper that basically, because the solutions are, they're reaching out, and they're, in fact, I say it's positive pressure. They want to sort of ingress into the physical world, but I also, think that we could view them as agents as well, that are like trying to, they have goals that they're trying to meet. So what makes, what is it that makes either certain people or certain systems or the right hemisphere, um, what distinguishes the cases where you're able to invite in this amazing pattern versus examples when you're not, and you sort of have to slowly crawl to it? What is,
Yeah.
right? I mean, that's kind of what I'd like to know.
Well, I mean, to come crashing down to neuropsychology on that one. I mean, all the descriptions involve a not knowing, a letting go, a potential space that can be filled, and it's often said in you know in Eastern traditions that there is this idea of emptiness, but not emptiness in the Western sense, which is of something negative. It's emptiness which is the potential space into which something rich and new can grow, rather like a womb has to be empty to begin with in order that the life can grow. So I think everybody, the scientists, the artists, the sages, say that there is an important period of fallowness in which one is not striving too hard. But on the other hand, you have to put yourself in the way of it happening. And so it may be necessary to do, as Wordsworth described, that you have to strive, you have to read, you have to think, you have to approach the problem, and you won't get it while you're doing that. But you won't get it unless you've done that, and then you drop it, and then the answer comes. Now, why that should be, it seems to me the most logical way to think about that is that the right hemisphere has extremely wide ranging connective paths, and it has a greater facility for making distant connections than the left hemisphere. And the more one engages the left hemisphere, the more these connections become tightened down into almost like concentrically into an area where you're focusing your attention. So that it may be that what's happening is that you need to sort of do that and let it go. I mean, it might even be like exercises one can do physically in order to relax, which are to tense one's muscles and then actively let go of the tension. And that allows something to... Does this make any sense, or am I just completely way away?
No, it makes total sense. I think that's I think it's particularly interesting down at the lower levels where we can say you've got particles and molecules that they're not confused about what to do. They don't make mistakes. The chemistry just does what it does, and it chooses the lowest path every single time, and it's great. Then you have a paramecium, and the paramecium is now in the same bind as we are. It has to make decisions rapidly with limited information. It can misperceive, it can make mistakes, all kinds of things. That layer in between, right? What happens? How do you get to that level? Because we can see all the, in these very simple life forms, we can see all the molecular events happening. And even, some of the things that we're doing in between, like we found the learning capacities in molecular networks. And so what I'm really interested in is formulating a notion of search, of striving, of navigation in the molecular networks, because we have to have pictures of it all the way down. And I think it will be very simple, but I don't think it's crazy to think about problem solving. We know that happens in cells. I don't think it's crazy to think about it in molecular networks, and all of the things that we think of as creative, the creative search for problems and preparing yourself to sort of, I don't know, be in resonance with this download of information that is trying to get to you. If I think there's a molecular story to tell about this that I would like to do, and I think it also links to some of these ideas of the mind as a filter. It's an old idea, and right, and
it's very much my idea too.
Yeah, right. So there's an element of this where the more computational capacity you have, in a certain sense, it's actually preventing you, right, from finding certain things.
Absolutely, but of course the negation. I mean, another point I think is very rich is that in our world we think of negation as, well, negative, whereas in fact negation is highly creative. And an example is Michelangelo creating a sculpture. He doesn't put anything together. All he does for several years is throw stone away, and at the end of it, it's there. So there is something, and for him there must have been something calling to him in the stone that enabled him to do this, to find it, if you like. So what are your speculations about how this might work at the molecular level? Have you got any thoughts at this stage?
Yeah, I think well, there's a couple of things. One, there's a rich set of findings coming from mesoscale physics and solid state physics, where there's actually some amazing papers showing how when you vibrate a medium a particular way, things that belong together in the sense that they're going to bind nicely to each other. Actually, when you watch the paths, they actually sort of are like navigating it. It doesn't look random anymore, but there was nobody's guiding it. There is, at least from overtly. There's no
No,
algorithm
yeah,
for it. There's no mechanism for it. So there's
no.
there's some stuff coming from physics around that. For me, I think we really need to think about these issues of to take seriously this idea that basically what's happening is that there are various kinds of patterns. Some of these low agency things that mathematicians deal with, the fact about the prime numbers and such, and then but other of these patterns are the kinds of things that Patrick Grimm was looking at or beyond that we would recognize as kinds of minds or behavioral propensities or things like this, and that
Yeah.
some of these, I mean, this is part of that discussion about machines versus organisms and all that, because I'm completely okay with acknowledging, if we have to acknowledge that there are the things we call organisms are a completely different type of pattern than the things we call simple machines. Obviously they're different, but I think we drastically underestimate the material and the level of complexity that you need for that to start to happen. We've been investigating this, as you know, in the sorting algorithms and some other crazy stuff that isn't published yet because we're still getting data. But there's going to be some wild things coming down the pike on this, where basically I just
Wonderful.
I just think that we have to be humble about the fact that we are not good at predicting what kinds of simple things are going to serve as pointers to some very sophisticated patterns, and therefore we have to be really careful before we label things as just machines and so on. That's we just don't know, and I think figuring out that relationship between the thing you build, whether it's a physical object, whether it's an embryo, a biobot, a computer, whatever, the things we build, and the things that it pulls down, because it pulls down things that you did not expect or in fact
Yeah. Yeah.
make provision for.
Yeah, I mean, that would come on to the question of ethics,
Right.
which you raised, and I think is important, but we can come back to that. But I don't see any reason why, if there are not just, if you like, forms, these apparently non-physical forms that ingress into phenomenological experience and cause changes in physical bodies. But also, I mean, I'm interested in increasingly in the idea of goals and values as being very real parts of the structure of the universe. And I think that one way to look at, I mean, it's interesting because science has quite legitimately and very productively stated that it is going to explore things without reference to direction, purpose, or values, and that's very useful, and that's been very important. But what science cannot say at the end of the day is that it has discovered there is no purpose and there is no values, because it ruled them out and it had no competence to find them, if you like. But if one gets beyond that, there is nothing anti-scientific. It is complementary to science, that science sees a world that does have directions and is lured by certain values. And I think those values are, and you find them very much in the stories of mathematicians coming to their conclusions, that there is something beautiful in them, that they are beautiful and complex, and that generally speaking, the universe has a tendency to produce things that are beautiful and complex. I mean, one of the things that I forgive me if I'm repeating myself, that I often think, along with Whitehead, who is an influence on me very much, why is there life at all? Because if it's all about being able to remain in existence, and beat other things that remaining in existence, then the answer is never to have been alive, because you can live for billions of years as a mountain, if you like. But once you start really being alive, your lifespan is limited, but not necessarily that limited, because there are these actinobacteria in the base of the ocean that are single examples of which are about 1 million years old. So evolution has not actually, its purpose doesn't seem to have been that of making a single organism last for longer. It's been, to end up with people like us that stick around for 70 years or so. So what is it about? And I think what it is about is this drive towards complexity, towards responsiveness, towards the resonance with whatever the source of energy that grounds everything manifests. There's a resonance between us and it. I mean, I'm positing that everybody imagines there must be something that grounds being. We may not ever know what it is, and we may have to say, well, we just leave it at that. But whatever that is, it doesn't seem to be entirely neutral, because the universe that it has grounded is not just a random set of things bumping into one another. It has order, it has beauty, it has complexity. And I think these are drives. And I think that what life offers is, if you like, that interdependence I was talking about before, in which there is a kind of dance, for want of a better word, between that ground of being and the living, in which the potential that is stored there, that is manifest in this explosive universe, is being realized in certain ways, so that it can actually bring something about that reflects something back to the origin, the ground of being. Now, the reason why I think that is important is that I see that potential is extremely important and is often thought of as less important than actuality. And here I'm with, forgive me, Heidegger, who said that it's quite possible that potential is more important than actuality. Now, yes and no, but the potential is no good unless anything gets actualized. I mean, an example I give of that is money. Money is potential. There it is. And actually, it's nothing until it's actualized. It is the potential for all kinds of beautiful experiences and things to be made and happen. But it has to be spent in order that those things can come about. So the amount of potential diminishes. The sort of free potential diminishes and becomes an actuated part of experience. Now, I may be misunderstanding Whitehead, but I think that is, his terminology is an off-putting element for me, but I think that is what he's actually talking about, is that when things come into being, they then add to the sum of what there is, so that when new things evolve from this field of potential, those actualities have enriched it, and they become more likely to be expressed the next time round. And so I think this explains the continuity and the persistence of certain forms, not the rigid insistence on those forms, the general persistence of those forms over time, that they've been precipitated out of potential into actuality, and they now change the nature of the universe ever so slightly, if they're small things, but nonetheless they do. And that what we are seeing is the unfolding of potential into actuality all the time.
Mm-hmm.
What do you think?
Yeah, and especially so I've been playing with models in which the so if we assume that there is a set of patterns of widely differing complexity and agency that are trying to get into the physical world, then one of the things that happens with evolution could be you could easily have this positive feedback loop where when evolution right, it benefits from access to these free lunches. There's many useful things you get that you don't need to specifically evolve because of these laws of mathematics and computation that just kind of are there for you the minute you make a voltage gated ion channel, and boom, now you have truth tables and all this amazing stuff because they're basically transistors, and you don't have to evolve a truth table. You just have to make the protein. And so but the feedback loop comes because as much as you take advantage of those kinds of free lunches, that enables you to build a more sophisticated interface, meaning a better embodiment, which immediately gives you access to other more sophisticated forms, which then immediately enables you to make another more sophisticated embodiment. And so it's like it's as you said, it's a co-creation or a co-evolution of right of these things that are kind of potentiating each other,
Yeah.
you know.
No, fascinating. And I suppose, to come back to the machines thing, it seems to me that if these forms exist, and there seems to be very little way of accounting for things unless one accepts that something of this kind is the case. And if they do have values and direction and purpose, then why would they not, for good or ill, get instantiated in machines? Why would it be unreasonable to suppose that, a highly complex AI did not actually itself express certain values and directions? And as you say, we might get some surprises because we don't know exactly what we're doing there. And so, I mean, it's not a reason to sort of be a Luddite, but it is a reason to be quite careful about what it is, to be aware of what it is we don't know. I mean, effectively, that is the most important thing for any scientist to be aware of, is what it is he doesn't know, not just what he does know.
Exactly. And it's funny, both ends of, in my experience, both ends of the opinion spectrum are finding it very hard to appreciate that point, because you have the people who actually make the things, and they say, I've had people say to me, well, I build these AIs, I know what they do, it's just linear algebra. I said, well, you're just biochemistry, aren't you? Like yes, of course. You make them, but if you don't know what they do, if you don't know what bubble sort is doing, then you sure as heck don't know what this thing is doing. And then there's the opposite side. I had the organicists who are extremely interested in a very kind of a sharp distinction, right, between these things. I gave a talk to a group that was like in the kind of Indic philosophy traditions, right? And they were I thought that some of these things that I was saying would be right up their alley in terms of these ingressions that basically come to haunt physical bodies and so on. They were adamant that no kind of AI could have any of this, because it was, as they called it, dead matter. And I said, well, first of all, I don't think there is any dead matter. There are lazy observers, but I'm not sure there is any actually dead matter. But also, given the overall worldview that you have this non-physical mind that is somehow embodied in physical, but who are you to say that if you build a beautiful synthetic embodiment, some mind, it might not be remotely close to a human mind, it might be some very, in fact, probably it'll be from some very weird untapped region of the space of minds. Who are you to say that this thing is not allowed to come and sort of animate this in a certain sense, this novel embodiment? I mean, how, on what basis? But they were just completely adamant about that wasn't going to happen.
Yeah, I mean, I think one can't be adamant about anything in this area. One has to keep a relatively open mind and be aware of what that means. So, but yeah, it is an interesting point. Anyway, yeah. You said somewhere something I'd like you to expand on. I wrote it down. I'll see if I can find it. Yeah. Yeah. You say the mechanisms by which these anatomical pattern memories are stored, recalled, and implemented have been described. And I wondered if you could tell me more about that. I mean, where are these anatomical pattern memories stored, recalled, and implemented?
Yeah, I will tell you, but it is not the same as the additional question of where they come from in the first place, and
No, quite.
that's a whole other thing.
No,
As
I could see you were separating those questions. Yeah.
Well, there's right. I think there's, yes, I think there's separate questions. The conventional side of this story is that we can now see, both as a matter of biology experiments and also computational modeling, how circuits made up of biorealistic elements, meaning ion channels and gap junctions, so these electrical circuits, they basically make an excitable medium. And this excitable medium can support, as long as it's alive and there's energy to do so, they can support a number of stable modes. And you can think about this, it's like Turing patterns in mixed chemicals. It's like basically when you create the network, it will spontaneously, and I think evolution does a very good job of fine-tuning the channels so that by default, when the system is up and running, basically embryonic development, it settles on a reliable pattern. And you can see this pattern. And when I say pattern, I mean it's a distribution of voltage gradients across a set of cells. It's not a single cell thing, but let's say you have 1,000 by 1,000 cells. It's a patch of tissue, and if you look, you can actually see. Okay, well, there's a the electric face is that we found as one example of this, where you have this thing and it's spontaneously, and we've now generate a bunch of computational models that show how exactly this happens. It basically settles from a homogeneous state. It settles into a state where it's got two spots is where the eye is going to be. It's got a spot where the mouth is going to be. It's got some stuff around the outside for the placodes, and that thing is stored and maintained within the electrical state of the cells, and it's compatible with the biophysical properties of the channels. And then it is read out by other cells, which are basically paying attention to this pattern and using it to determine what genes should I express, where should I migrate, what should I differentiate into. And we know these things are instructive because if I recreate that pattern somewhere else, this is how you get an eye on the tail or an extra leg or a repair brain defects and things like that. So the maintenance and the readout of these things are now, I mean, we've been at it for 25 years, but that we have now a handle on. But then of course there's the other thing, which is that, for example, in planaria heads, so they all have different shapes. There's triangular ones, flat ones. When you perturb, and they're extremely robust, so we know that a set of genetically encoded hardware elements spontaneously will settle on one attractor for head shape, and it works very reliably. But we also know that if you perturb that electrical decision-making process, they will just as happily visit head shapes, attractors in the space for other species. And so now—
I saw your work on that, yeah.
Yeah. So now we have to ask the question, right? So this is my point about mapping out that space. We have to now understand how many attractors, why these and not others are there. Is it and actually I wanted to ask you about this too. Whether you thought the space was sparse or just continuously filled. In other words, there's Michelangelo's statue that was calling to him. Around that, are there an infinite number of almost as good statues, or really like there are like I don't know.
No, not surprisingly, I don't know either.
Yeah.
There are a couple.
Go ahead, please.
No, there are a couple of thoughts about that. I mean, presumably going to the question, but how does that pattern? You've suggested that there is a pattern and you can see that there's a place for the eyes and so on, but how does that pattern arise? Is that going too close to the other question? We don't know where these things come from.
No, well, how we know how. So if you want to track, basically we can track and computationally predict all the steps from zero. In other words, you start with, much like Turing did. This is one I think one of his genius things is that he was interested in intelligence, but also in the self-assembly of the body, right? And I think he saw that these were the same problem. And in Turing patterns, it's kind of similar. You start with a well-mixed, random field of chemicals, and before you know it, you've got some tiger stripes or some leopard spots or some things like this. And there's a precise mathematical a formalism that shows you exactly why that happens. The same thing is true here, except it's in electrical. Actually, who was it? I forget who it was, but somebody pointed out that actually the form of the math for Hodgkin, Huxley, and some of the original Turing diffusion stuff is actually very parallel. But regardless, we have the model showing when you start with a field where all the voltages are basically equal. Given the properties of the channels, spontaneous symmetry breaking and amplification will give you certain kinds of patterns, and some of them are the kinds of things that we're interested in, such as face and so on. And you can watch this happen step by step. I mean, the how of it is much like with Turing patterns is okay, you know. Now, but the part where we now have to understand what the available modes are, and and what the bidirectional interaction is that I think pulls some of these planarian and other things into these attractors. That's a whole other thing. And there are some other fascinating things that are
Yeah.
all not understood. But the how of it, at least, we've got now.
Yeah, that's what I was thinking, is that describes the how, but it doesn't describe the why of the thing being like that at all. Um, or at least so it seems to me.
Well, the why, I mean, this is exactly when we get into. Yeah, I think we need to know what we would accept as a proper answer to the question of why, because you know this is where we get into those, for example, those fractal shapes, right? The why of any piece of mathematical truth is, so why is it like that? Because there isn't a fact of physics that's going to give you an answer. There isn't a fact of history, meaning
No,
evolution, right? There's no evolutionary
no.
support. What else? What are the other tools in our toolbox for answering why questions? That's that now we're getting into an area where I don't even know what a good answer to that would be.
Well, there might be an answer of the kind that the reason that the tadpole's head reconfigures completely as a frog's head, and we can explain some of the step by step of how that happens. I'm sure. I mean, it's just a matter of not just, but it's a matter of very clever observation. But it is a matter of observation. Whereas where the information, the information of the having to go from the one head to the other, where is that, and why does it inhere or ingress in the way that it does? It seems to me another kind of question. That's all.
It is, and one of the reasons why I started talking about this, I mean, I've been interested in this stuff for decades, but the reason I started
Sure.
talking about it more recently, where I never talked about this before, is that I think we now have even more practical tools to start addressing some of these questions. And for example, what I'm really interested in are the unexpected patterns that manifest in synthetic bodies that have never been the target of the selection specifically, such as anthrobots, xenobots, these weird chimeras that we make, right?
Yes, yes.
Because we can talk about people who want to have a very kind of minimal ontology. They don't want this Platonic space. They say, look, when you say forms, these are just stable evolutionary. These are things that evolution has learned over time. This is a good way to make a frog. This is not a good way to make a frog, and that's all there is to it. And so I'm interested now in all of these examples where there is no history of selection to lean on. These things never existed before. There's never been
No,
any pressure to be a good xenobot or a good anthropod or any of this other stuff.
no, no.
And being able to predict and make use of these things for medicine, for biorobotics and whatever,
Yeah, yeah.
requires that we give up this magical notion of emergence as well. It's just a fact that holds about the world. We'll catalog them,
Oh, yeah, 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 yeah,
as they come up, right?
yeah.
And commit to some sort of systematic investigation of what are the patterns in addition to the ones that evolution has found. What are these patterns? Can we find them? Can we, right? And can we make new
Yeah.
patterns that will
Mm,
pull down the ones we want, and by the way, avoid the
yeah.
ones we don't want, which I'm sure
No,
are.
don't want. Yeah, yeah. Well, it's a noble aim. Do you think that there's a worry in it?
I do think there's a worry in it, because I think we are now in many ways, and I think we have been for a long time. We're just not good at recognizing it. We're dipping into a pool of patterns that maybe have never been.
Yeah.
We've
No,
never,
exactly.
maybe certainly not on Earth. Maybe nowhere have ever been
Mm,
embodied before. And
no.
there are dangers in it on both ends. There's the obvious thing that people talk about, which is what is it going to do to us, right? That's
Mm,
one set of things. But equally important is the question: what is its experience going to be? What do we owe novel beings
mm.
novel minds right, that we're bringing into the world? This is a perennial
Absolutely.
question.
It
And
is. It is. Yeah, yeah. No, no. Very good. What would you have to say about the planarial head having the ability to solve a maze. So you can see this form of the head, and you can change the form of the head, but where are its memories?
Do you mean behavior, you mean behavioral memories?
So you know that if a planarian has solved a maze, or even a slime mold has solved a maze, and you cut bits off it,
Yeah.
the daughters can you can destroy, burn the head of the planarian, and the new head will know how to solve the maze. Have you thoughts about that? How that comes about?
Yeah, good point. So McConnell found this memory surviving regeneration of the brain back in the 60s. We actually showed this using modern techniques in 2013. So we built an automated device that completely automates the training and testing of planaria in that assay, which was important because McConnell would get like his experiments. You had to manually, someone would sit there with a pencil and say, oh, I saw this thing turn right versus left, and they would write it down, and then people say, well, you're just imagining things. And so we made a device. It's this giant thing that automates the process, so we have videos now, so you can't, you can't say it's an observer but effect anymore. So and it does work. He was right. And I think there's a couple of things we can say. One is that one of the things this is showing is that memories can be, I they can, it's like I think there are two kinds of pointers, that two patterns, that point to these patterns. There is that, and maybe this maps onto your potentiality versus actuality thing. There are some pointers that are right now connecting us to that pattern. And this might be an existing body. It might be an engram in the brain, whatever mechanism. Different people study different mechanisms, right? Those are things that are guiding behavior right now. But I think what's happening in those planaria is that in that 8 to 10 days during which they're regrowing their brain, during which time they have no behavior, there's nothing going. The tail just sits there doing nothing. During that time, they still have access to that information, and we know this because the cells have to somehow. Well, I used to describe it as the cells having to imprint it onto the new brain, because that's when the behavior is really going to get going, is once the brain is there. So it had to have, right. The way I used to describe it is that it's the information is moving through the body. The cells are storing it. They're imprinting it on the new brain. So now I think more like what it is that I think we can say that behavioral memories are patterns in that space, just like morphological memories, and that the engrams in the brain are pointers to that information, and that the rest of the cells are in some way place holding it, such that when the brain is going to show up, it'll facilitate it to reconnect to the patterns that it had before. And we actually have lots of data on moving different kinds of memories, both anatomical and behavioral, into bodies by transplants. And one of the weirdest things is that it takes very little tissue to put in a new pattern into a large recipient organism. It really doesn't take very much at all. And this is still unpublished, but we have some work showing that if you cut a tiny little piece out of a two-headed worm and you stick it into a one-headed worm, not every time, but some percentage of the time, that little piece convinces all the other cells, which this is what's mind-boggling. Why are they going along with this? They should be suppressing this aberrant thing. But sometimes that story of being two-headed is really compelling, and it takes over the recipient worm, and you get two-headed worms which never saw the gap junction blocker, that it transfers over. And yeah, and so
Fascinating.
and
Yeah.
there's some clinical cases which you may have seen that are a little bit like that, of some personality changes coming along with things like stem cell transplants and heart lung,
Exactly.
I don't
Which
know.
are fascinating. Yeah.
It's super fascinating. I don't know if the data set is big enough to make firm conclusions yet, but I think it's very interesting. Um,
Yeah.
so that's my suspicion on this, is that I think these memories are patterns, just like the morphological patterns.
And I'm sure you're right to point outside of the mere bounds of the brain that these things can be stored, as you say, in heart, lung, other places. Quite how or what it is that's stored, I don't know. But the literature seems certainly not dismissible
Yeah.
on these changes that happen. What do you think of hydranencephalic individuals who, I mean, just for viewers or listeners, this is not just hydrocephalus, where a lot of the brain space is filled with fluid, and it's extraordinary that there you get people with very little brain compared to most people who nonetheless function normally and have a perhaps high IQ and can do mathematics to a high level. But with hydranencephalic individuals, there aren't that many of them that survive, but they have nothing in the brain space. So basically they stop at the brain stem and there's vestigial or no cerebral tissue. And yet they can in some form see things, they can interact with people in an emotionally intelligent way, they can have favorite toys, they can appreciate music. How the hell is this happening? What is going on? Have you any thoughts about that?
Yeah. This is a real problem, and Karina Kaufman and I just put out a review of some of that kind of stuff. Some of
Okay.
the famous cases. Uh, I, to me, the problem is I'm not super shocked that it's possible, just in the sense that I've already committed to this idea that a lot of the processing, as it were, happens offline, outside the physical embodiment. So okay, so that's fine.
Yeah.
But what is a problem, and what I don't have a good explanation for, is if it is apparently possible to have proper function without as much brain as we think, right? If one can access all that stuff with much reduced architecture, why is that not more? I mean, my understanding is that one thing that limits our this pressure on not having a brain that's too big because of childbirth and all this kind of stuff, and the brain eats up a tremendous amount of our daily energy rations. Why, if it's possible to do with less, why don't we with less? That's the thing that keeps me up at night. Is that right? Is that
I know.
right? These examples are showing you that it can be done with a lot less. Why is
It can be done, but I mean, of course, these are not, uh, by contrast with hydrocephalic subjects, these are not really fully functioning human beings.
This is true. I guess I was talking more about the hydrocephalic ones
Yes,
where you
yes.
even they don't, some of them don't even know there's an issue until they, for some
No,
reason,
no,
they
have a head scan.
they do a scan and oh my God, So right. So right. In that case, those cases are to me very weird. I don't understand why, why if that's possible, why isn't it just that all the time? You know,
Yeah, 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 yeah.
I don't know. I don't know.
No, no. You must tell me when you've got to go, Mike. But if you've got time, I'd just like to put an idea to you.
Please, yeah, keep going.
Okay, good. Um, One way of thinking about this potential versus actual thing is even more fundamental, which is Goethe's, I think, extraordinary insight that he said, dividing the united, uniting the divided is the whole business of nature. And then he goes on to talk about things in other metaphors, but I think the point is there, that the whole business of nature is dividing what is united and then uniting what has been divided. Now, to me, that is also a phenomenal echo of the right versus left thing, because the right hemisphere sees something as a whole, the left hemisphere takes it to pieces, analyzes it, which literally means breaking it up. And then the right hemisphere takes back what has been analyzed and recomposes it into a now enriched whole. So that is an important journey from wholeness to a divided wholeness back to an increased integrity of wholeness. And I suspect that this is actually part of the way that creation in general happens. Now, if you think about the potential and the actual, what is happening there is that the potential is collapsed into the actual, and it has very specific pinnable, downable qualities. But those qualities having been created in that way, are present in a way they never were before. So they now get taken back into the whole in a way that enriches the whole. Now, the reason I'm saying this is that it seems to me that when we talk about there being forms, and in my case, I'm not including you unless you want to be included in the idea that there are drives, purposes, directions to evolution, not just biological evolution, but the evolution of the cosmos in general. If that is the case, it may well be that there are analogues of the force for division and the force for union at very, very low levels. So going down to single cells, not just their reproduction, of course, and the whole process is interesting in reproduction, where the dance of the chromosomes, where they get divided and recomposed in a new form, but actually the whole business of the drives that are for good or ill part of life can be seen. I mean, it's a step. It's a large step, and it may be a step too far. I'm perfectly happy to be told that, but it seems to me that there might be some value in reflecting on that as resonating with, or actually being present at different levels in the cosmos, both the living cosmos and perhaps the non-living. I don't know if you've any immediate reactions to that, other than, oh wow, he's gone into some completely crazy space.
No, I don't think that's crazy at all, because this is something we think about a lot in terms of uh, how collectives form and what happens when parts join to be a collective, and how which in our case oftentimes is a pathology we try to deal with when there are breakdowns and things are, you know, sort of breaking up. But that actually that cycling back and forth, and probably it does go all the way down, is I think very interesting. We came across this Lakshman Shrisha, who's a student that I work with, was doing this model of it's this will be up on online shortly. Iterated prisoner's dilemma that is spatialized. So you have a bunch of
Oh,
agents.
okay.
They're all playing prisoner's dilemma against each other, right? But there's a twist here. Normally, in all of the analyses that we have ever seen, the number of agents is fixed. So you know how many beings there are. They all play against each other. There's a payoff table, and off you go. And then there's things that happen. So we added two things. We added, yes, you can cooperate or defect, but you can also merge and split. So what that means is that two agents
Right.
might become one, and then the whole calculus immediately changes. So what happens is it's this recursive thing where your decisions change how many individuals there are, and it changes the border between you and the world, right? So multicellular, basically you can, but
Right.
strange things start to happen because now your choices determine the number of beings in the world, which completely changes the calculus for you and your parts and everything. So all the
Of
math that
course.
normally that goes along with it doesn't work anymore, because you know it's all recursive, right? So anyway, so there's interesting stuff that happens, but one of the things that happens is that eventually you get bigger and bigger regions, and eventually you come to a position, and I didn't understand, I didn't foresee this at the beginning, and it took us some time to figure out what was happening. What we noticed is that eventually, so the energy level of these things goes up and up and up as they get bigger and bigger. So that's great. So we can see there's a drive towards multicellularity. Fine. But then it sort of reaches a cliff and falls off. And we said, what the heck is this? And we figured out what was happening. What
Yeah.
happened is when these guys merge to the point where there's one big agent, there's no one for him to
Right.
play with. There's no one for
Yeah.
him to play against. And so now
Yes.
it's kind of like asking, what's the fitness of the entire biosphere
You,
defined? Because there's no one to get,
no.
right. And so now you can imagine, we imagine three scenarios that can happen after that. The first scenario, and they roughly kind of match, I think, the scenarios that have been envisioned for the universe, for the end of the universe. So one thing is a kind of heat death, where look, you've gotten to your world, you've eaten all the food, that's it. Now everything dies. There's nothing more to do. That's one thing to do. But another thing to do that's interesting is this. As you get big and your energy level starts to drop because there are no more games to benefit from, one of the things that happens is stress builds up, and when stress builds up, you fragment. kind of like a kind of
Yes.
trauma causing a dissociative state, right? You fragment into pieces. As soon as you fragmented it into pieces, you can start to climb back again because now you can. So right, so now there's this big crunch thing where you sort of you start off as individuals, you join together into this thing, you fragment back, and you come in, you sort of can pulse, right?
Yep. Yep.
Back and forth. So you could do that, and then there's a third version which we haven't implemented yet, which is this. Maybe what happens is that once you do this and you've joined together, um, maybe what it allows you to do is now project yourself into a new space that was not accessible to you before. So in biology, we know this happens because individual cells that are navigating physiological and transcriptional spaces, they get together and now anatomical morphospace. Now we can do all these things we couldn't do before, right? So maybe they can escape now in our system, there was no way for them to escape the world because we coded it that way, right? But if we were smarter, we would have multiple layers where this thing can now escape the universe that it has sort of explored to the edges and right and go for. So I don't know, but I think what you said
Amazing.
about this kind of like basal joining and splitting is fundamental. And I
Yeah.
remember I remember Bernardo Kastrup and Rupert Spira saying on one of their talks that they thought that we are all, how do you put it? We are all dissociative alters of God. That's what he said. That we are basically, kind of like this dissociative thing, and trying to sort of work our way back. Right. That's how they put it.
I love all of that. Very, very resonant with my own thinking. And although I wouldn't say that we're all, I know what they mean, dissociated alters of God, but I think the point is this, that in every creation myth, there is the idea of this founding being, the ground of being, and it needs an other. First of all, because it is relational. Like all existence, it is relational, so it has to have something to relate to. And also, the otherness is creative. So the otherness, which seems like resistance or negation of the wholeness and beauty of the original, is also the path from which the manifest latent beauty and complexity can be unpacked. So it's part of the creative process. It's really a very fine idea. And I sorry, this is probably not what you normally talk about on podcasts, but I came across the extraordinary wisdom of the Kabbalah, the Jewish mystical tradition. And in the Lurianic Kabbalah, there is this primal being called Ein Sof, which is the ground of being. And he wants to create, as all these beings do. And so its first act is negation of itself. So the first act is to withdraw in order to make space for there to be something other than Ein Sof at all, which is an extraordinarily imaginative idea that actually needs to be the negation to be creative. And then in the space that is now vacant, there are placed these urns, which are to be the Sephirot. And the one spark of light comes, or spark of fire, I should say, comes out of Ein Sof and falls on the vessels and shatters most of them. And so that's the second phase of creation, called Shepharat HaKelim, the shattering of the vessels. And then there comes this third phase, Tikkun, which is that it's humanity's job to take back these fragments that now have sparks of divine fire in them and put them together to make urns that are more beautiful and more special and living, where they have divine life in them, than the original urns had. So that again is slightly like, again, this progression from the left to the right to the left, and the incorporation of this new element that may seem like it's a negation or a breaking or whatever, makes something even more whole and more beautiful than was before. I mean, I just put it forward because I think it's an intuitive, I think these really profound images and myths are not just, nothing. They are ways in which our minds contact the shapes, the forms, if you like, and see something that means something, not because we add meaning, but because we find the meaning that is there. Yeah. Anyway, that's what I'd say.
Fascinating. Do you think that is it a prediction of this view that with the wide potential variety of beings out there in the universe, that we are going to find some sort of, I don't know if it would have to be physically bilaterally, sort of organized, but that they would have to necessarily contain some component that is like the left hemisphere in its job, and some component, right? Like, is this a general architecture, do you think?
I would, of course, it's a mug's game predicting things about which one has no information, but nonetheless, I mean, that would be my supposition that this is so fundamental to the structure of everything, living and non-living, that yes, it would have to be reflected in some way. And that quite probably things like goodness, beauty, and truth would also be elements that are in this story. And there could be good and evil, there could be beauty and ugliness, there could be truth and falsehood. So
Fascinating.
there we are.
Yeah. So I'll just say this gives me an interesting
Yeah.
idea, which I probably should have realized before, that we have now the ability to collect calcium signaling data from xenobots and soon from anthrobots. I'm going to start looking for a lateralization of function. I wonder if in these things, which and by the way, we have neurobots now that have neurons, that we put neurons into these things that they don't have a standard architecture. They have some kind of crazy novel architecture. But
Yeah.
maybe we can find examples of this, of processing that's associated with integration versus versus reductive analysis. We'll take a look. We'll
I
take.
think that would be really fascinating. I can't wait to hear what you find. And what I love about your work is that you have, for a very long time, not dismissed the idea that asymmetry is extremely important, as well as that there needs to be something beyond the simply mechanistic vision. So, thank you very much for your time and your wisdom.
Thank you so much. Likewise, yeah, this has been amazing. I took a bunch of notes actually as we were talking. So thank you. It's a very
Okay.
so yeah. So we'll
Okay.
talk more. I'll
Great.
I'll keep you apprised. There's some stuff coming that should be quite relevant to this. So I'll keep you apprised.
That that's fabulous. Thank you very much, Mike.
Thanks, Ian.
And will
Well, of
you will you will you send
course,
the tape to my
absolutely,
people? Yeah,
absolutely.
thanks very much. Yeah,
Okay, thanks, Ian.
tape. You know how old I am.
I know tape. I say it all the time too. Yeah, yeah, from the tape. All right,
Thank you very much.
we'll see you.
Bye.